Hello, my name is Stefan Wysocki. I'm working for Tieto and contributing my Android experience from last couple of years into vehicle data API subgroup of Android Automotive SIG. So during this 30-minute session, I'm going to present the status of implementation of each component that is defined for external data server approach. At the end, hopefully, I will show the demo of the concept described here. So, as you might remember from the previous technical summit that took place in May, Vehicle Data API Group is focused on accessing the vehicle data in a standardized way as much as possible. Of course, taking into account the industry use cases, the problems, and the expertise from previous platforms. During the last workshop, we have established the following architecture: the data server that is located outside Android and is able to provide the vehicle data to its clients. In our case, the client is the head unit that is running with Android on it. However, right now we need to exercise two paths. The one that is able to access the signals directly by using GraphQL, and the other one to satisfy the Android framework needs. To do that, we've agreed to have the POC realizing the concept of retrieving the data from the fuel subsystem. And so let's imagine the application that wants to read the current fuel and the tank capacity. But before that, we need to agree on something. So we've established some kind of requirements that also came from the industry, like read access needs to be protected in this approach by permissions that is granted by some authority which is secure enough. So in our case, it will be a package manager which realizes all permission aspects in Android. So then vehicle data needs to follow already established standards like VSS, and also the data needs to be accessible by the framework as well to provide an access to legacy applications. Okay, so let's focus more on each component individually, starting from the Android components to the one that are outside Android. To realize the access control based on Android permissions, we need to authenticate the request that came from the application. To do that, we have implemented the component that is exposing the API to, let me say, sign the request by providing the token with the permissions bundled inside. This is working. The service is able to generate the token with authentication data. However, we did not discuss yet about the security aspects, like token signature validation and encryption itself. We still have some sessions planned for today, so we might discuss it there. So I encourage everybody to join, especially if you have some security concerns or backgrounds on this area. Another framework component are actually components that Android framework use. It's the vehicle hull. So here we used some draft implementation thanks to Tieto of the vehicle hull that provides the possibility to write the plugin that fits only a subset of the properties required by the framework. So it took some kind of a boilerplate required by Google. So we were focused only about writing the interaction with GraphQL. So other properties are provided by a default implementation of the Tieto Eurovehicle. So yeah, based on that, we have implemented the GraphQL plugin that is connecting to the data server and retrieves the exposed data signals by some predefined queries. Then it fills, then it passes the data to the core of the vehicle hull, and then it's passed to the Android framework, and the apps can use it using standard Android car API. Right now, the support is limited to GET and subscribe calls, not only in the vehicle page but also in the data server. Data server is still not able to actually accept the set methods to change some values that exists outside Android. So, as I said, to showcase the architecture, we implemented the application that is directly using GraphQL to connect and actually query the server and use authentication service to generate the token with permissions bundled. The token is passed in the same request as the query to the server to authenticate, and then server will decide whether it's the application is eligible to read the data that we want to read. To show the framework path, we are using the Kitchen Sync, which is an Android application using Car API, and is already available in the AOSP builds. So I'm sure that somebody of you who were working with Android Automotive already know that application. So it has a various of purposes, but there is a one subsection to test the framework in regards to properties. So we are using that way. Okay, so let's proceed with the components that are planned to be existing outside Android, because we have some. Like this VSS feeder component, which is responsible to supply the data server with the actual data. In our case, it writes the signals from OpenDS simulator into the SQLite database. And the SQLite database, however, was not yet aligned with CCS project, but this is some kind of plan to be that aligned, to done that alignment. Right now, it is a simple key value store with the keys representing VSS leaves. Last components that are valid are the Apollo GraphQL server and the database, which is the SQLite, which we already talked on the previous slide. To the access is realized actually by Apollo implementation GraphQL with some simple resolver that resolves the query and returns the needed values from SQL database. So VSS feeder is putting the data, Apollo GraphQL is pulling it from the database and send it to the application. The permission concept is still not finalized. This topic is one of the points that needs to be covered during the workshop session. So yeah, going to the next session about the conclusions that arise during the implementation and the future plans that indicate the direction, and hopefully some party from the group can be encouraged by this to join our weekly telcos and contribute. So one of the conclusions is like this discovery that there is no straightforward GraphQL library that abstract the implementation for serializing the queries and deserializing the results. And there is actually, the library is not existing for, to be specific for the native services. So If we go in this approach, I mean this architecture, I suspect that our reference design needs to have it, even a simple one. So it will add additional work to create some kind of serialization of the queries for GraphQL. Yeah, because we need to know that not all the services and applications will be written in Java or Kotlin. Because right now this Tieto every VHAL is written in C++, and exposing the luckily exposing the Heidel interface for its plugins. So we have some kind of a chain there. So we have the Android Heidel, then we have some kind of vehicle HAL, which is taking over some implementation of the subscription and so on. And then we have multiple instances of the plugins which are communicating with the core of the vehicle HAL as running as different process. So that's making us the possibility to make GraphQL Java implementation of the VHAL, just to use the Apollo GraphQL Android client library, which is existing in the Apollo project. Other thing is the real-time subscription query. Without this, we need to pull the data from the server continuously to measure the trend of the property value. So it generates a lot of the traffic around the socket. So the last conclusion is about the tricky configuration of Android part. One thing that we want to highlight that still Android vehicle HAL is not frozen. It means that even with the treble, there are still changes in the vehicle property names and the structures between Android version. It is really problematic. It needs to be resolved somehow. So if you want to provide a mapping between VSS values and the ones that are introduced in Android, we or the OEMs need to maintain the multiple Android releases at the same time to have different mapping between different structures of the properties. What about future plans? For sure, permissions enforcement is something worth to check. Implement the real token security to secure the integrity of included permissions inside the payload. Updating the property values from Android, however, still looking for the use case that can be presented using our setup. We do not have obviously any peripherals connected right now, so we need to use the props that are provided by OpenDS simulator. The last thing that's starting to begin, actually starting to begin the reality is the restructurization of the source repositories that we have. So as an output, we will have a Genevieve flavored device that contains the configuration of the packages used by each milestone. For this, we will use the standard Android approach with the repository manifest plus a local manifest Git that will extend the AOSP source tree with Genevieve flavored components. There is also a proposal to unify the branching strategy to maintain multiple Android version. It is aligned with the audio HAL subgroup since they are more dependent on the version of the Android and the hardware. For non-Android components, one repository with sub-repositories. So in that approach, we will have trackable sources with link dependency between the components kept as other Gits. Okay, so let's see how the described components behave in practice, actually. So first, let me start the OpenDS simulator and show some track. And okay, while launching, we could start the Docker with non-Android components like data server and the data feeder. Okay, engine on. We are ready, so we could start the Android head unit, which is running on, in that case, in Android 10 emulator variant. We can see that there is some traffic already for the server part. So the vehicle is running, so we could open the modern approach and request for the fuel value. Okay, we can see that the level is read from the data server and the token is actually generated. We could copy it and verify the token if it contains the permissions. Yeah, so we can see that that there are encoded permissions agreed to be used for retrieving the fuel. So yeah, let's check if the fuel level is decreased after running some meters from this car. So yeah, so right now we are using this modern approach. It means that the application is requesting for the token for just for this application, connecting to the GraphQL directly without using the Android approach. No, it looks like it has very low consumption, so it still shows 99%. Yeah, but it only said that the granularity is not that, it's not sufficient for that case. So right now we are going into Android application that use standard Android Care API and check the value for the fuel level. We can see that the value is in the, it's translated from the VSS percentage to the milliliters that Android expects. So while driving, we could also subscribe for the properties, and its values are displayed in the logs here. So we could subscribe for the fuel level, for the gear selection, and all that messages or signals are coming from the data server, and are realized by a simple polling of the right now by a simple polling periodically the server. Okay, so it's almost all that I have prepared. Let's go to some kind of a slide with summary. If you want to contribute, if you want to join our telcos, our weekly telcos are happening at 5 p.m. Central Europe time. It is a pre-recorded session that you're listening to, but I will join the workshop for sure this afternoon and be happy to answer all your questions that might arise during the presentation. So thank you and see you soon.